We've lost more than half the sea ice that used to be around in the 80s. We're continuing over this last decade this ever-increasing loss of ice during the summer, but also this startling thinning that's been going on as well. There's so much ice lost that the Arctic is in a new state. We're finding that it's thinner now, and that thinner ice is easier to melt than thick ice. And so all of this is setting the stage for predictions of an Arctic that is ice-free in summer months somewhere in the coming decades. So what we're talking about is the Earth's northern polar ice cap. What that's made of is ice that's floating on top of the Arctic Ocean. And this is ice that's anywhere from like 3 feet at the thinnest to about 20 feet at the maximum. And we're interested in this ice for a couple of reasons. The first thing is right now it functions like a giant mirror on the top of the planet. When sunlight comes in, it reflects those rays of light back into space. Ice has very different reflectivity than water. As that ice retreats, we get more dark water exposed. Now that incoming solar radiation gets absorbed and it heats up the water. And that also increases the amount of ice that melts. Every winter it grows, and then every summer it melts back. The reason people are concerned right now is that in the past few years, we've seen a dramatic summer melting that takes the ice back to a point that's far, far, far smaller than we've ever seen it before. And in 2009, we set the stage for another year of this continued melting and reaching what are near record lows. The loss of Arctic sea is profoundly important for the globe for a number of reasons. First of all, it's one of the biggest knobs on global weather. We have an ocean that used to be covered with a solid surface that's going away. It affects the position of the jet stream, which will now extend further north and further south and cause blocking patterns that could increase those periods of extreme heat and extreme cold in the US. That's just kind of the simplest thing. It could also affect storm tracks like Superstorm Sandy. It could also affect globally those weather patterns, and those are the kind of cutting-edge research questions that we're working on right now. The Arctic has massive stores of methane in the permafrost and also on the seabed. As we lose the sea ice, we have more heat going into the ocean, and we can also transport that heat, cause more permafrost thawing, destabilize the seabed, and potentially trip the release of all this methane, which could cause big spikes in global temperature. The polar regions heat up faster than the rest of the planet, and that's exactly what we're seeing in the Arctic. Finally, the Arctic is just one of the most fascinating, least explored places on Earth. You know, you have the amazing animals like polar bears, and you have this really interesting ecosystem involving things like algae forming near the surface and sinking to the bed and creating this rich benthic environment that walruses then come in and exploit. And all of that is changing right now in real time. We use a range of satellites to document the sea ice and understand its connection to the global drivers of change. We also have some of the most sophisticated research aircraft in the world, and we fly over the ice and shoot at it with lasers and radars, and we have other devices to measure variations of the Earth's gravitational field and magnetic field, all to understand what's going on with the ice. You need to think of this ice as being continent scale. Is it ice that's a foot thick that's covering everything, or is it little patches of ice? That's not the whole story. We also need detailed studies. We're interested in how rough is the surface. In some places, it's smooth, like that pond in the Midwest that freezes every winter. But in other cases, that ice has been blown and crunched together, and we get ridges and mounds and things like that. We don't just work on the sea ice, we also study the glaciers of Alaska, the Canadian ice caps, and the Greenland ice sheet, where there's been a lot of changes in recent years. Our satellite data shows us that Greenland is not just losing more ice, it's accelerating in its ice loss, and it's losing ice not just from the warm south, but also from the cold northern regions. And what people need to understand is that this isn't just one study or one type of data. We bounce lasers off the ice to measure the height. We use radar to study how fast the ice is flowing. And we actually use a satellite called GRACE orbiting the Earth that directly measures the mass change itself. Simple fact is, we're losing a lot of ice out of Greenland. Antarctica is also a fascinating place, and we're losing a lot of ice from Antarctica, particularly West Antarctica. The problem is, again, we're characterizing continental scale areas and we're looking at subtle changes in ice. In some areas along the coast, from satellite, we can see that we're losing 30 feet of ice a year. Some of this, though, is balanced by the amount of snowfall that falls in the interior of Antarctica, and we're working out that balance now. But overall, Antarctica looks like it's losing a lot of ice. It's so obvious that this is happening that people that live in the Arctic regions and the countries that border the Arctic are planning facilities based on there being less ice. There are people building warm water ports. There are oil companies preparing to do exploration. People talking about using it as a transportation route. But also the Arctic peoples that live there, they're observing these changes. And they're saying things like, hey, we used to be able to walk out on the sea ice, and now we can't do that anymore.